So let us now discuss problem number 2. So we have a certain soil profile here which is made up of sand at saka yung clay natin. So for the sand, meron tayong dry sand at saka yung saturated sand. Yung clay naman natin, that is already saturated. So paano ba natin malalaman kung dry or saturated yung lupa natin? So kung titingnan natin dito sa figure, ito yung sign, ito yung location ng groundwater table natin. So in this part, from this point, pababa, magiging saturated yung lupa natin. And of course, meron tayong bedrock dito. So for this, yung layer 1 natin, which is a dry sand, meron siyang height which is equal to h sub 1. Tapos naman, yung second layer natin, which is a saturated sand, meron naman siyang height which is equal to h sub 2. And then lastly, yung third layer natin, meron siyang height na h sub 3. So for this, meron tayong soil stratum, A, B, at saka C. So sa kada soil profile natin, sa kada layer, nag-iiba yung mga values natin. So nag-iiba yung values ng H1, H2, at saka H3 and its respective unit weights. So for us, ayan. So pinapa-calculate sa atin for letter A, calculate the variation of, hahanapin natin yung variation of the total stress, which is denoted by sigma sub T, yung effective stress, which is denoted by sigma prime, and lastly, yung pore water pressure natin. O yung pore water pressure natin, it can also, yung representation din natin dyan is small u. So let's consider first yung soil A natin. So hanapin muna natin yung total stress. So para mahanap natin yung total stress, so gagawin lang natin dyan is yung unit weight multiplied by the height. So dito, we have a given dry unit weight which is equal to 115 multiplied by yung height niya which is equal to 2 plus sa second layer na tayo. So yung unit weight ng second layer natin, it is a saturated unit weight. So you will have 118 multiplied by yung height niya which is equal to 4 feet. Plus, yung last layer natin, it is a saturated clay having a value of 130 and a height which is equal to 6 feet. So, yung value ng total stress natin is equal to 1,482 pounds per feet square. So next, paano naman natin kukunin yung sigma W o yung pore water pressure natin? So ginagagawin lang natin dito is imumultiply natin yung unit weight ng tubig dun sa height ng mga layers na affected dun sa tubig or dun sa height ng mga layers na may tubig. So for this one, yung H1 natin, wala naman diyang tubig, so hindi natin yan ilalagay. Yung second layer natin, since it is saturated, meron siyang tubig, so ilalagay natin yan dun sa imumultiply natin sa unit weight ng tubig. Lastly, yung last layer natin, it is a saturated clay, meron siyang tubig, so gagamitin natin yung height ng saturated clay. So kung ko-compute natin yan, since naka-pounds at saka feet tayo, so gagamitin natin unit weight ng water is 62.4. So, yung h sub 2 natin for this one is we have 4. In sub 3, that is 6. So, yung value ng pore water pressure natin is equal to 624 pounds per feet squared. So, sunod naman, paano naman natin hahanapin yung effective pressure? So, dealing with the total stress, so okay lang na may tubig yung lupa. Kapag naman sa effective stress o yung sigma prime natin, dapat mawala yung tubig. So, for this, gagawin lang natin, we have sigma T minus yung sigma W natin. So, aalisin lang natin yung tubig dun sa total stress natin. So, we have a total stress of 1, 4, 8, 2. Tapos, yung pore water pressure natin na 6, 2, 4. So, you will have a value of effective stress which is equal to 858 pounds per feet squared. Or meron tayong other solution in computing for the value of your effective stress. So, paano natin kinocompute yun? So, you will have, ang gagawin natin is, so, aalisin natin automatically yung value ng tubig. So, for this, since dry sand lang tayo, as it is natin gagamitin yung unit weight. Kasi wala naman yung tubig, multiplied by the height na 2. Plus, eto naman, since we have a saturated sand second layer, 118 na unit weight, saturated unit weight, ima-minus natin yung value ng tubig. So, for this, aalisin natin yan ng tubig. So, ima-minus natin yung 62.4. And of course, imumultiply natin yung h sub 2, which is equal to 4 feet. Lastly, i-add naman natin yung third layer natin. So, meron siyang saturated unit weight na 130. So, aalisin natin yung tubig dyan. So, since naka-English unit tayo, so that is 62.4 multiplied by yung height niya, which is equal to 6 feet. So, kung i-compute mo yan, you will have a value of your effective stress, which is equal also to 858 pounds per feet squared. So, ganun lang yung solution natin. Then, let us solve for soil B naman. So, paano natin? Iso-solve naman yan. So, for this one, so let us consider soil B naman. So, hanapin natin yung total stress natin. So, that will become, so yung total stress natin, multiply lang natin yung mga unit weights natin. So, that is 16.2 multiplied by 4 plus 18.4 multiplied by 1.5 plus yung last layer natin na merong saturated unit weight na 18.91 multiplied by 9. So you will have a total stress which is equal to 262.59 kilonewton per meter squared or kilopascal. Next naman, paano naman natin kukunin yung sigma W? So, imumultiply natin yung unit weight ng tubig. Since it is in kilonewton at saka meter, gagamitin natin is 9.81 kilonewton per cubic meter multiplied by heights ng mga soil na merong tubig. So, sa H2, meron niyang tubig. At saka yung H3, meron niyang tubig kasi nga saturated yung sand at saka yung clay. So, yung H2 natin dito has a height which is equal to 1.5. Tapos, yung H3 naman natin has a height which is equal to 9. So, yung pore water pressure natin, that is equal to 103.01 kilopascal or kilonewton per meter squared. So, lastly, let us solve for our effective stress. So, for this, gagawin lang natin is yung total stress, aalisin lang natin yung tubig. So, you have yung 262.59 minus the value of your pore water pressure na 103.01. So, sigma prime is now equal to 159.58 kilopascal or kilonewton per meter squared. So, next, paano naman natin i-compute yan? Alternate solution. So, for the alternate solution, in computing for the value of your effective stress, so since yung first layer natin, that is a dry sand, so hindi na natin i-minus yung tubig dyan, kasi wala nga tubig, di ba? Kaya nga dry. So, you have 16.2 multiplied by 3, by 4 pala, plus yung second layer natin, which is a saturated sand na merong 18.4 na unit weight. Ma-minus natin yung tubig na 9.81 kilonewton per cubic meter. And then, imumultiply natin sa height niya, which is equal to 1.5. Plus, yung unit weight ng saturated clay na 18.91, ima-minus natin yung value ng tubig na 9.81 multiplied by yung height niya which is equal to 9 meter. So, yung value ng effective stress natin is equal to 159.58 kilopascal. So, ganun lang kasimple yung pagkuha ng mga total stress, effective stress, at saka yung pore water pressure natin. So, for soil C, ayan, given yung void ratio, pati yung specific gravity, so kukunin muna natin yung value ng mga unit weight natin. So, let us proceed in the computation ng mga unit weights natin for soil C, for first layer, second layer, at saka yung last layer natin or yung third layer. So, let's solve. So, let's solve for dry unit weight. So, for the dry unit weight, for first layer, so, since dry yan, gagamitin nating formula is the GS, unit weight of water, over 1 plus E. So, we have a value of specific gravity na 2.65 multiplied by, since nakameter tayo dito, so gagamitin natin is 9.81 kilonewton per cubic meter over 1 plus yung E natin, which is equal to 0.52. So, our dry unit weight is now equal to 17.10 kilonewton per cubic meter. Next, how about the saturated naman? For the second layer, we have a saturated, tapos sand, that is equal to GS plus E multiplied by unit weight of water all over 1 plus E. So, meron tayo dito na 2.65 plus yung E niya which is equal to 0.52 kasi parehas naman silang sand, multiplied by, since naka-meter tayo, gagamitin natin is 9.81 over 1 plus 0.52. So our gamma saturated sand is equal to 20.46 kilonewton per cubic meter. Then next, let's compute for the gamma saturated clay naman. So, yung formula natin is same lang. So, we have A. So, hindi pala kasi wala naman tayong given na GS. So, meron lang tayong given na moisture content. So, given yung moisture content at saka yung void ratio, yung formula na gagamitin natin, that is equal to void ratio multiplied by 1 plus W saturated multiplied by unit weight all over 1 plus E multiplied by W saturated. So, kung isa-substitute natin yung mga values natin, so we have a value of our E which is equal to 1.22. This is equal to 1.22. Yung W natin o yung moisture content natin in decimal, that is 0.45. W saturated, that is equal to 0.45. So, yung value ng gamma saturated clay natin is equal to, so yung gagamitin natin unit weight dito, that is 9.81. So we have a value of gamma saturated clay equal to 17.37 kilonewton per cubic meter. So let's say, mag-shortcut na lang tayo dito. Hanapin na lang natin yung value ng effective stress. So for the computation of your effective stress, or sigma prime, so yung dry unit weight natin, that is 17.10, multiplied by yung H1 natin, which is equal to 3, plus yung sa second layer natin na merong saturated unit weight na 20.46, aalisin natin yung tubig na 9.81, multiplied by yung height niya, which is equal to 2.5, plus, so you have a saturated unit weight ng clay, which is equal to 17.37. Aalisin natin yung tubig na 9.81 multiplied by the height, which is equal to 2. So, the value of our effective stress is now equal to 93.05 kilonewton per meter squared. So, ganun lang yung shortcut natin in the computation of our effective stress. So, next problem. So, for letter B, if the water table rises to the top of the ground surface, so what is the change in effective stress at the bottom of the clay layer? Refer to problem C. So, for this one, so mangyayari ngayon for this one, so yung water table natin will rise on the ground surface. So if it will rise on the ground surface, so eto na ngayon yung bagong water table natin. So from this, pupunta siya sa ground surface. Ngayon, tinatanong sa problem, what is the change in the effective stress at the bottom of the clay layer? So, hahanapin ngayon natin yung stress natin at the bottom ng clay layer and ko-compute natin yung change dun sa effective stress. So, kung nandito na yung groundwater table natin, so, mangyayari yung first layer natin, magiging saturated sand na siya. So, instead na gagamitin natin yung dry unit weight, gagamitin natin yung saturated unit weight. So, for this problem, nakalagay dito, refer to problem C, or dito sa soil C natin. So, gagamitin natin properties etong soil C natin. So, for this one, since parehas lang naman na sand to, tapos parehas yung mga properties niya, so kung ano yung na-compute natin na saturated sand, yun din yung value ng saturated sand natin dun sa layer 1. So, let us calculate for the value of our new effective stress. Sabihin na natin effective stress final na lang. So, you will have, so yung unit weight, saturated unit weight natin dito, that will become 20.46. Aalisin natin yung tubig na 9.81 multiplied by the height of 3 plus, so you have 20.46. Aalisin natin yung tubig na 9.81 multiplied by yung height niya, which is equal to 2.5 plus yung saturated clay natin having a value of 17.37 minus 9.81 multiplied by yung height niya, which is equal to 2. So you will have a new effective stress, which is equal to 73.72 kilopascal. So that is 73.72 kilopascal. Next naman, hinahanap dito sa problem natin yung change in effective stress. So let us calculate for the value of the change in effective stress. So yung difference nung final at saka yung initial. So yung final natin, we have, so yung initial natin dito, ma-minus natin siya sa final. So we have a initial value of 93.05 kilonewton per meter squared nung nandirito tayo sa original groundwater table. And then, nung tinaas natin yung groundwater table, yung bagong effective stress final natin, naging 73.72. Or in other words, biglang bumaba yung value natin. So, our change in effective stress is now equal to 19.34 kilopascal. So, ganun lang kasimple yung problem number B natin. So, therefore, kung titingnan natin, habang tumataas yung groundwater table natin, lumiliit yung value ng mga stresses na nararanasan ng soil profile natin. So, habang bumababa naman yung groundwater table natin, tumataas yung value ng effective stress natin. Next, for the problem C, how many meters must the groundwater table rise to increase the effective stress by 100 to 100 kPa at the bottom of the clay layer? Refer to problem C. So for this, yung hinahanap is So i-increase daw natin. So from 93.05, i-increase daw natin yung stress natin dito sa bottom ng clay layer natin ng 100 kPa. Yung tanong dito is, gaano kalayo yung groundwater table natin from the bottom of your clay layer? So sabi ko nga, diba, habang bumababa yung groundwater table natin, o yung GWT natin, groundwater table, tumataas yung value ng stress, effective stress natin. So for this, from 93.05, gagawin natin siyang 100 kilopascal. So how many meters must be the groundwater table rise to increase the effective stress to 100 kPa at the bottom of the clay layer? So gawin natin reference yung bottom ng clay layer natin. So hahanapin natin yung value ng H natin. So sabihin natin, ito na ngayon yung bagong groundwater table natin. So this is our new groundwater table. So from the groundwater table hanggang sa bottom ng clay layer natin, so designate natin yan as capital H. So next naman yung pagbaba ng groundwater table natin, sabihin natin that is small h. So this is small h. So ngayon, paano natin hahanapin yung value ng h, small h, at saka yung capital H natin? So siyempre, we're going to refer dun sa statement na nakalagay na yung effective stress down natin magiging 100 kPa. So we're going to use this one. So burahin na lang natin to. Ayan. So mangyayari niyan, yung effective stress down natin magiging from 93.05 magiging 100 kPa. So you will have, so 100 kPa is now equal to, so eto nyan, from dun sa kanina na naging saturated yung sand natin, ibabalik natin siya sa dry sand. So yung dry sand natin, we have a value of 17.10. Kasi nandito na yung groundwater table natin eh. So you have 17.10 17.10 multiplied by, so yung height niya, we have h sub 1. So yung h sub 1 natin, referring to problem C, or sa soil C natin, we have 3 plus. Kasi binaba natin yung groundwater table, etong soil layer natin sa layer 2 na merong height na h, magiging dry yan. So since parehas naman silang sand, so ilalagay na lang natin dito para isahan na lang yung computation. So, yung dry sand natin magiging 3 plus h plus eto namang sa layer 2 natin. So nandito rito yung groundwater table natin, meaning to say from the groundwater table pababa is saturated na siya. So gagamitin natin is the saturated sand having a value of 20.46, aalisin natin yung tubig, multiplied by the height. So yung original height niya, dun sa soil profile natin is H2, which is equal to 2.5. Kaso nga lang, bumaba nga yung groundwater table natin by a value of H. So mangyayari niyan is 2.5 minus H. Plus, lastly, yung clay layer natin having a saturated value which is equal to 17.37. So you have 17.37, i-less natin yung tubig na 9.81, multiplied by yung h sub 3 na lang which is equal to 2. So by shift solve, we can now calculate for the value of your small h which is equal to 1.08 meter. Next, paano naman natin kukunin yung capital H? So that will become yung H is equals to eto. So this is equal to 2.5 minus H na 1.08 plus yung H3 natin which is equal to 2 meter. So yung computation natin for letter B tsaka letter C, yung reference natin is soil C. So the value of our H is now equal to 3.42 meter. So ganun lang yung computation natin for problem number 2.